The universe is a vast and mysterious expanse dotted with wonders beyond our imagination. Among these enigmatic phenomena, black holes stand out as some of the most intriguing and awe-inspiring entities. In this journey through the cosmos, we embark on a quest to explore these cosmic giants, delving into their origins, growth, and the astonishing sizes they can reach. Join us as we unravel the secrets of the universe's most formidable entities, the black holes. The largest things in the universe are black holes. In contrast to things like planets or stars, they have no physical size limit and can literally grow endlessly. Although in reality, specific things need to happen to create different kinds of black holes, from really tiny ones to the largest single things in the universe. So how do black holes grow, and how large is the largest of them all? This video will not discuss how black holes work or how they form, since we've looked at that in detail in our black hole and neutron star series. You can check them out afterwards. For now, we are interested in finding the largest thing in the universe. Let us start really, really small. Primordial black holes. The smallest kind of black hole may or may not exist. If they do, they are probably the oldest objects in the universe, older even than atoms. They would have formed just after the Big Bang, when the universe was so dense with violent energy that any tiny pocket that was just slightly more dense than its neighbors could produce a black hole. The smallest primordial black hole that could still be around would be 1 trillion kilograms or so, the mass of a big mountain, and yet they would be no bigger than a proton. A primordial black hole with the mass of Earth would barely be larger than a coin. This makes them very hard to find, so we haven't actually observed any yet. If they exist, they may even be the mysterious dark matter that holds galaxies together. Let's move on to the kinds of black holes that we know for sure are out there. Stellar black holes. To make a black hole, we need to compress enough matter so that it collapses into itself. After that, the more mass we throw at it, the larger it becomes. In today's universe, only the most violent cosmic events can create the necessary conditions, such as the merger of neutron stars or when the core of a very massive star collapses in a supernova. To have a unit to work with here, we'll use the mass of our Sun, about 2 million trillion kilograms. The smallest known black hole has 2.7 times the mass of the Sun, which works out as a sphere around 16 kilometers in diameter, large enough to cover Paris. Another lightweight black hole is the companion to the V723 Mon red giant star. This star is 24 times larger than our Sun, 30 million kilometers in diameter. And yet, it is thrown around by a tiny black hole just 17.2 kilometers wide. This tiny thing bullying the star is so much smaller that we can barely even show them in comparison. One of the largest known stellar black holes is M33X7. It currently spends its time eating a 70 solar mass blue giant bit by bit. As all that stolen matter circles towards the black hole, like water going down a drain, friction heats it up to temperatures high enough to shine 500,000 times brighter than our Sun. And yet, X7 is only 15.65 solar masses and 92 kilometers wide, just big enough to cast a shadow on Corsica. To grow much larger, black holes have to either devour a lot of stars or, better, merge with one another. The instruments that make it possible to detect these mergers are very new, so we are currently discovering a lot of exciting things, like 2 massive black holes that we detected in a galaxy 17 billion light-years away. As they spun around each other violently, they released more energy in the form of gravitational waves than the combined light from all the stars in the Milky Way in 4,400 years. The new black hole they formed is about the size of Germany and is 142 solar masses. And here we hit a curious gap in scale. There are lots of black holes up to 150 solar masses, and then there is nothing for a long time, until we suddenly hit black holes that are millions of times more massive. Which is a bit confusing because we had this idea that black holes are consistently growing and growing. But for the most massive black holes, this process is not fast enough to explain their existence today. The universe is simply not old enough for these supermassive black holes to have formed by eating stars and merging with each other. Something else must have happened. To explain how we got the largest black holes in the universe, we might need the largest stars that ever existed, quasi-stars. To get a sense of scale, we can compare them to the largest stars that exist today. Our Sun is like a grain of sand next to them. We don't know if quasi-stars actually existed, but they are an interesting concept when it comes to supercharging black hole development. The idea is that the matter in the early universe was so dense that quasi-stars could grow to thousands of times the mass of our Sun. The cores of these stars might have been crushed by their own weight so much to actually collapse into black holes while the star was still forming. In contrast to stars today that would destroy themselves in the process, inside quasi-stars, a deadly balance could emerge. Gravity pressed the supermassive star together, feeding the black hole and heating the material, falling into such a degree that the radiation pressure kept the star stable. And so these quickly growing black holes might have been able to consume the quasi-star for millions of years and grow far bigger than any modern stellar black hole. Black holes are several thousand times the mass of the Sun and wider than the entire Earth. These black holes might have become the seeds for supermassive black holes. Wow, did you ever imagine that black holes could be such cosmic powerhouses? From devouring entire galaxies to bending the fabric of space-time, these celestial marvels truly redefine our understanding of the universe. But our journey doesn't end here. There's still so much more to explore in the vast expanse of space science. So don't stop now. Keep watching, keep learning, and keep exploring the wonders of our universe with us. Hit that subscribe button and join our community of space enthusiasts to stay updated on all our latest discoveries and adventures. Together, let's continue unraveling the mysteries of the cosmos and expanding our horizons. Thanks for joining us on this incredible journey, and remember, the universe is waiting to be discovered. Until next time, stay curious, stay inspired, and keep reaching for the stars.